Imagine a computer so powerful that it can solve problems in seconds. Problems that would take even the world's fastest supercomputers thousands of years to complete. Sounds like science fiction, right? But this is exactly what quantum computing promises. To understand this, let's start simple. Traditional computers like your phone or laptop use something called bits. A bit can only be in one state at a time, either 0 or 1. Everything you do, from watching videos to playing games, is built on this simple system. But quantum computers are completely different. They use something called qubits, or quantum bits. And here's where things get really interesting. A qubit can be 0, 1, or both at the same time. This is known as superposition. Because of superposition, quantum computers don't just try one solution at a time. They can explore multiple possibilities all at once. This makes them incredibly powerful for solving complex problems. There's another concept called entanglement. This means qubits can be connected in such a way that the state of one instantly affects another, even if they are far apart. It's something that even scientists once thought was impossible. Now let's talk about Google's quantum computing efforts, including systems like what people refer to as Willow. Google has been leading the race in quantum technology, building machines that push the limits of science and engineering. These quantum computers don't look like normal computers. Instead, they are large, complex systems filled with advanced hardware. One of the most important things about them is temperature. They operate at temperatures close to absolute zero, colder than outer space. This extreme cooling is necessary to keep qubits stable and reduce errors. Unlike normal computers, quantum machines are not measured by RAM or storage. Instead, their power depends on the number of qubits, how stable those qubits are, and how well the system can correct errors. Error correction is a huge challenge in quantum computing because qubits are very sensitive to even the smallest disturbances. Google has already demonstrated something called quantum supremacy. This is when a quantum computer solves a problem that a classical computer practically cannot solve in a reasonable amount of time. This was a huge milestone in computing history. Now you might be wondering, what can quantum computers actually do in real life? The possibilities are massive. In medicine, quantum computers could help scientists design new drugs much faster by simulating complex molecules. In cybersecurity, they could both break current encryption systems and also help create stronger, more secure ones. In weather forecasting, quantum computing could lead to extremely accurate predictions, helping us prepare for natural disasters. In artificial intelligence, it can improve machine learning models and solve optimization problems much more efficiently. Even industries like finance, logistics, and space research could benefit from this technology. But despite all this potential, quantum computing is still in its early stages. These machines are extremely expensive, difficult to maintain, and require very specific conditions to operate. They are not something you can carry in your pocket anytime soon. However, progress is happening fast. Companies like Google, IBM, and others are investing heavily in this field. Over the next few years, we may start seeing real-world applications that can change industries forever. Quantum computing is not just an upgrade, it's a completely new way of thinking about computation. And the big question is, are we ready for that future? Let me know what you think in the comments, and don't forget to like and subscribe for more tech content.